So now we're going to discuss about the practical implementation of income classifier. But before then, I would like to introduce you the steps which we're going to use while designing the project. How we're going to start the Jupyter from the very beginning, from the basics. Let's have that. It is very easy to install Jupyter. Let me stop it and restart it again for you. I have to type cmd and I just have to type pip install install Jupyter. Since it is already, so you have to type this one pip install Jupyter. I'm not going to install again, but maybe it will going to wipe out my projects. So install it, and after then you have to install pandas. My requirements are already satisfied, so I don't need it. My requirements are already satisfied, so I'm not going to. It will take some time. I think yeah, requirement already satisfied. Same thing is that pip install install. You have to use numpy also, right? And if you need some other libraries, then you can install them from anywhere. Now you don't going to, I strongly believe and I strongly advise you all that you change your directory so to some another directory apart from C. Go to say E drive, which I have chosen, and I have make a folder known as Jupyter, and I just go inside that and I'm going to run my Jupyter server. It is Jupyter Jupyter NOT notebook, right? Moment I run this one, it's going to open my notebook, and I have two examples at this point of time with me. First one is income classifier, second one is divine classifier and regression. So I'm going to start my income classifier with you all, right? So if you don't want to install your packages from there from command prompt, then you can have an option to install it from here by writing this exclamation mark pip install sklearn, which is a very big library for the machine learning applications, scikit-learn, which we also call it. And then we have exclamation mark pip install seaborn, which is a very exotic library for building the very good graphs, very good plots, charts, etc. So since I already have all these requirements satisfied with me, so I'm not going to run them again for me. So the heading is classification of personal income into two different categories, as I have discussed. So first one is required packages. The packages which we're going to use here is are import pandas as PD and import numpy as NP. So first of all, what is a pandas PD? So pandas is a library which is responsible for working with data frames. What that this means? A data frame is just like a frame or a normal window frame which composed of columns and rows. Please mind it very carefully. Please mind it very carefully that these rows, these rows are your vectors, and mind you that these columns are your components, and number of columns are there. They shows number of dimensions. Of course, when I am saying this particular thing, I am not including the dependent variable or target variable. So we can say that 1, 2, 3, 4, 5. 5 independent variables are there and one dependent variable is there, right? So we can say at this point of time from the graph which I have made there, we can say that our input was belonging to 5 dimension input and our output was belonging to one dimension. right? So no, I was saying about pandas. So pandas play a very important role in creating data frames, and data frames are extensively used. It has different type of functions like at df.loc, df.iloc. Please go through them. They are very important if you want to learn data frames, because without learning data frames, you will not going to have a grip on machine learning. Right. So pandas SPD is a very important data frame for it's a very important library for accessing data frames. Then we have the another very important package known as the NumPy. All the mathematical computations, whether they are related to matrix multiplication or they are related to matrix addition or they are related to any other activity, the NumPy package play a very important role. We always use lot of functions of NumPy just by using the NP. We can have np.array to convert a list or a series into an array. Normally, it is very important to mention here is that the data which is being fed into the model is always preferable to be of type array. And here I would like to bring in your information, and maybe you are going to study very soon, or you have already have the existing knowledge of this particular fact that the TensorFlow always takes the data in the form of array. So it's strongly recommend that they convert the data into one-dimensional array, which is also known as tensor. So what is a tensor? A tensor is a one-dimensional array, right? Similarly, when we are talking about NumPy is NP, we basically talking about numerical package NP. NumPy stands for numerical package, where we can have lot of operations, matrices, non-matrices, or we have mathematical calculations, mathematical computations, arranging data, and accessing data using range function, arrange function, right? So all mathematical computations are being handled by the by this particular one, a revel rv, a revel which is used to remove all different type of dimensions into a single dimension, reshape to convert the data into again into single dimension, right? So now another very important library is known as Seaborn library, which is being imported from which is imported as Seaborn as SNS, and it is used to work with visualization. Then to partition the data, that is to divide the data into different parts, we're going to use sklearn's model selection train test split. Train test split is a very great utility. It is being used to divide the data into following parts: train underscore x comma test underscore x comma train underscore y comma test underscore y is equals to train underscore test underscore split and then your data set. So this lies there: train, test, and split. After then, some important libraries which we have used in implementing the logistic regression classifier. From sklearn.linear underscore model, I have imported logistic regression classifier. Here, I'm going to again put my views on logistic regression classifier, which is a effective binary classifier. Divide the data into two parts, that is 0 and 1, but it has a particular threshold, and that threshold is normally being taken as we can say that it would be say y equal to 0.5, right? Anything less than zero point 0.5 will be treated as 0, and greater than or equal to zero point 0.5 will be treated as 1. So our threshold is there, which is always be quite compelling, and try to achieve the results. But the sigmoid function which we are using in logistic regression, I just like to put in your mind somewhere that always be care about this particular thing, that it gives the rise of vanishing gradient problem. Vanishing gradient problem is a very big problem which is there in machine learning. It is under the eyes of the researchers. Researchers are working on it and trying to solve it very soon for you all. Right? So it is important that you should have an idea about the vanishing gradient problem whenever you surf on internet or you have your resources regarding that. Please go through that and see the meaning of what I'm saying, vanishing gradient descent. After that, we're going to have library for performance of matrix accuracy score and confusion matrix. Now here very important thing which has come in front of you all is, which I would like to explain you, and which seems to be confusing in itself also, that is confusion matrix, which shows 0 1 and 0 1. It is true negative, it is true positive, sorry, it is false positive, it is false negative, it is true positive, it is false, remember. F, false positive, false negative, true positive. Right. So precision is nothing but it is true positive upon predicted positives. So what we have to predict, actual predicted is this one. Predicted positive means true positive plus false positive. So predicted can be replaced with true positive upon true positive plus false positive. And recall says that it is nothing but it is true positive upon actual positive. Actual positive. So you have to make it again here, 0 1, 0 1, true negative, false positive, false negative, true negative. And recall says that it is true positive upon actual predicted, false positive plus true positive. And precision actual, I'm sorry, this is not there, it is actual, yes, it is true positive upon false negative plus true positive. Actually it is true positive upon actual, yes, recall. Precision is true positive upon predicted, yes. Please mind this difference. After then, after implementing this thing, this is all about the confusion matrix. So we calculate the precision, we calculate the recall, we calculate the accuracy, which is true positive plus true negative upon total number of data sets, is known as accuracy. And then we have another concept known as importing the data. How data is going to be imported. So it is very easy. You just have to go to your E drive. I just going to show you all exactly what is meaning. Look at here, here's my data income, and I just have my path here, eat here Jupiter. I've just posted here, and I have a full data set here, that is income.csv, right? So it is clear cut data which is showing that income is there. Let me run it for you all again, so that you're going to have a better view of this particular thing. Now since data is being Data is being read by CSV. So data underscore income is equal to pd dot read underscore CSV. And now we're going to create the original, we can create a copy of the original data. So data is equal to data underscore income dot copy, and that is basically nothing but it is a deep copy of the data. So a deep copy of the data is being created here. We can say that here in this particular section a deep copy of the data is being created, and we're going to work on this particular data. Why we are doing this thing? We are doing this thing because we don't want our data to be involved in this whole process, and we just want this data to remain safe, as safe as possible. So data comes out to be equal to data underscore income dot copy. Now, after then, since we have all these important tasks clear, why we have implemented all these things, I have dig deep into the model and try to bring out what is the reason for writing a particular statement, why we are writing this particular statement. It has to be very much crystal clear, so that only then we're going to have some benefit of learning, and we can make sure that the model which we are building is up to the mark, is one of the best model. Now we're going to perform exploratory data analysis. Exploratory data analysis means that we're going to perform it in two steps. First one is known as the data processing missing value, where we're going to look for the cross tables, we're going to look for data visualization, and after doing that, we're going to implement it using the exploratory data analysis, and we're going to check the particular independent variable against the target variables, their impact on the data process altogether. Here print data.info, right? So let me run this again. Data.info, we're going to have so many data sets here available for you. Age, we're going to give what is the age, working class, final weight, education underscore num, marital status, occupation, relationship, race, gender, capital gain, capital loss, hours per week of work, native country, income, right? So all these are the independent variables. Only this one is a dependent variable, which is known as the income, which is nothing but it is your target variable, right? So all other are the input variables. Now the game starts. In the input variable section, we have to do all the feature engineering activities, whatever we are aware of. Right? We're going to have the normalization. We're going to have the outliers removal. We're going to have number of things which we can do in building the data set efficient and as well as effective, right? So another thing is that look at this, everyone has non-null components. That means the data which is being describing here is consist of this number of rows it has, and its data type is integer, it is 64 bytes, and it does not contain any null values. Then it has object class is a working class. It would be like 10th pass, 11th pass, something like this, or some profile working, whatever you say, going to have this. And then final grade, education, electronic educational numbers, marital status. So categorical, non-categorical, all type of data sets are there, and we have to filter out the important components from them, and we're going to implement them on our data sets, on our models, of course, which we're going to build. Now, in process of proceeding that, we're going to have data dot is null. What it will going to do is that data dot is null will going to make sure that data which you are preparing is containing any null value or not. If it is not containing any null value, then it will going to give false, false, false. if it is containing any null value, we're going to give 2. So you can see here that it is not providing any null value. So does that it exactly means that it is not having any null value? No, it may have null values, or sorry, it may have some missing values. Necessarily, not possible that it would not have, it would not have any missing values or garbage values, but they are not in the form of nans. They are not proper null values. They are garbage values. So how are we going to get the idea about them? For this, for since this gives the detailed structure, we use some method. But here, some method is saying that it has no null value in age, it has no null value in work class, it has no null value in final weight, it has no null value in education, it has no null value, educational number, no null value, marital status, no null value, occupation, no relationship, no race, no gender, no, and so on. And in last, one of my favorite, income is also having no null value. That income, what is income? Income is your target variable. Remember, income is your target variable. It has also no null value. So, what can be done now? Let us go and switch towards the data.describe. And here we got the summary. This summary we're going to give you an idea about a discussion. Like, look at this age column, and please look it in detail. What does this age exactly means? Age says that we have total count of 48842, and the mean age is 38, standard deviation is 13, minimum age is 17, 25% of people are of mean age 28, remaining 50%, if I will say, then I'm going to have the mean age 57, and 75% people, 75%, we're going to have the mean percent 48, and maximum age is 90, right? So if we divide the data into chunks, then for every other chunk, we have different age as the main component. And it's okay, but this shows that okay, dispersion is very much dispersion is not there in the data. Similarly, for all other remaining numerical values, we have applied describe, which is going to say that what this is about the chart which we get, which contain count, mean, standard deviation, minimum 25%, 50%, 70% of the data. After then, hours per week simply says that mean 40 hours of work has been done. Of course, that would be per week, and variation of standard deviation of 12 hours. 12 hours standard deviation means that if we draw the graph of, if we draw the normal curve, we can say that that like then we can say that 65% of the people work with 28 to 52 hours, right? And this component is 65 to 66%, and it keep on increasing or decreasing on both sides of the normal curve. This is how you're going to read this one, right? Now the same summary can be applied for the categorical variables also. The categorical variables simply say that I have misspelled the spelling of variables. VRIA variables. And here, when we have to describe the categorical variables, we just have to write data.describe include equals to O. So O basically make ensure that the categorical variables only come for describing, and we don't have the continuous variables for describing. Then we have the summary of the categorical variables, and the summary of the categorical variables we're going to have these components that are work class. If you look at the work, we're going to look each and every component very cautiously. So the first categorical component is work class, and with the count of it has 48,842 counts. Unique values are 9. This indicates that there are 9 unique values in the working class. That means 9 category of people are there in the attribute known as working class. And which one has the toppest? Toppest is private. That indicate that in this particular data, maximum people have the working type as private. And what is the frequency of this private? If you see, the frequency of the private is more than 33,906. That means you can say that around 80% people are private, which indicates further that the government jobs or other sectors are not very effectively involved in this particular data. So a big eye-opener data which shows that the privatization is working more efficiently in creation of jobs as well as getting the employment. Then another word, which another keyword is education, or we can say that the categorical variable is education, which has 16 unique components, and out of these, the topmost is high school graduate, which has a frequency of 15,784 members. Then we have the marital status. In marital status, again, we have the same set of data. We have 7 unique components. I'm amazed that even in marital status also we have 7 different components. The most favorable is married spouse, and it has 22,379 total number of data values. Then we have occupation. The occupation has 48,842, out of which 15 are unique, and professional specificity is 16,172. Then we have the relationship. Relationship is at top, husband is there, and 19,767, 76 is there is the total frequency. So that indicates that women also have a better sense of judgment, and they are also there in the income classification group. Then race, white are very much more, in fact, more than 90%, I think so. And in gender, we have male and female, out of which massive frequencies of male candidates. And that then we have native country income, out of which highest is of United States. And as far as the income level is being concerned, the people who have income less than 50,000 seems to be more than those persons who have income greater than 50,000. Now, this being done, let us now calculate the frequency of each and every category. But you're going to find that moment you do this particular thing, moment you do, oh, I'm sorry, this was not being run by me. Yeah, moment you run this particular thing, what data, what class dot value underscore counts, you're going to get some new one new variable. One new variable you're going to get, and this new variable is nothing but this one. This new variable, what it indicates is a very important matter. This is a type of null value, which is really a spoiler, and there should be a proper appropriate way to deal with this spoiler. How we're going to deal with this spoiler is very important, and we should have a particular proper mechanism through which we can make ourselves assured that we're going to deal with this particular spoiler. Let us say that is it everywhere in every attribute. It is there in education. Well, no, in education it is not there. It is there in marital status. No. It is there in occupation. Yes. We have found him again. Here we are. Okay. Then it is there in relationship also. No. It is there in gender. Race. No. Gender. No. Yeah. It is there in native country also. Yes. So it is there in 3 4 attributes. There in target variable also no, it's okay. So to overcome this one, what we did here is that we have built these sets, all possible placeholder with all possible ways to have the gaps, right? And then we run this one. And we take the sum. Moment we run the sum, we find that work class had maximum 2799, occupation has 2809, and native country has 2857. If they were not having the placeholder in the same context or in the same row, then we're going to lose big amount of data. Otherwise, if some matching would be there, then a same row will going to be dated for every placeholder, so less loss would be there. Let us see what we're going to have. Now you can see that some nans are there, and we're going to drop them straightforward. Okay, so new data is going to be there. We have just going to drop those components which contain nan values, and the axis is equals to 0. What does this means? Axis equals to 0 basically means if we say axis equal to 0, that means we are talking about the rows, and when we say axis of 1, we are talking about the axivity of the columns, right? And then we have relationship between the independent variables. To see the relationship between the independent variables, we want to use this particular statement, which shows that correlation is equals to data underscore new dot corr, and this is what we get correlation. We're going to analyze it very carefully. Correlation is going to be analyzed very carefully. Yeah, here we are. First of all, what is the best way to look at the data set is to look one variable and its correlation with other variables. It doesn't have any big positive correlation, or it does not having any big negative correlation, so it's okay. Check this one out. It is also okay, no problem. Educational number, it's okay. Capital margin, it's okay. Capital loss, it's okay. Hours per week, it's also okay. So I don't think that we have to drop any column from here on the basis of on the basis of we can say that correlation, right? So correlation is not a matter of concern here. Now we're going to move towards the cross table and visualization. Data underscore node columns. So these are the columns which we have in our data set. We're going to use the cross tab. Cross tab is basically used to count the number of values separately. So gender is equal to PD dot cross tab, index is equal to gender, column equal to count, number is equal to true. So we can say that 32% are females, 67% are male in our data sets. So a good function cross tab. It's going to give you the table of the attribute and their and it table of the attribute which you want to print, their specific values and their count. If you put normalize equals to true, then it will going to give the percentage of trueness in that. Remember. Now we're going to have the gender versus salary status, or we also call it income. Income. So gender and salary status is new gender column and new gender. Actually, we're going to we're going to see that we're going to see that what is the impact of gender on income, that males are earning more or females are earning more, right? We're going to see that particular thing in that way. And we can see this here in this particular table that income is categorized into two categories: less than 50,000 and greater than 50,000. For female, we have 28% persons who are earning less than $50,000, and they are 0.036% who are earning greater than $50,000 in females. But in male, we have 46% who are earning less than $56,000, but they are 21% who are earning more than 51,000. So 51,000 or 50,000 is a very good benchmark in United States to live, right? Now let us have frequency distribution of the income. So you can easily see that the number of people, you can easily see here that the number of people who are having more income is who the number of people who have income less than 50,000 are very higher. That means around about 34,000, and those persons who have less than who have greater than 50,000 is relative 10,000, right? So we can easily see that these persons have very high value. So what we get from this particular figure, why we are using this figure? We are using this figure to identify that which particular portion has the what is the exact statistics of the income, and we have found that out of this particular data, whatever we have, the number of people who are having income less than 50,000 is more, not only more, that it is threefold in comparison to approximately 2.5 fold in comparison to those persons who are getting income greater than 50,000. So government needs to give more subsidies to the persons, right? So government going to have more expenditure on the data sets. Sorry, more expenditure on the resources by for giving them the subsidy, right? And then let us look at the histogram. What does this histogram tells us? This histogram tells us that The shape goes like this, and we can see that the peak. If you look at the peak here, then you can see that maximum people are of age for near about 40 to 45, right? Maximum people are of age 40 to 45 who are actively earning, and intuitively, of course, as the age is decreasing, the the number of people earning people are also decreasing. So maximum people available for who are earning are in this particular section, which is around about 35 to 47, and also high earning people are there. So so I think that government has to give subsidies, and of course they will be earning high also, right? So I'm thinking the subsidy would going to be there for this particular section only. I think so, or this particular section, because they will be earning less. Then box plot. What this box plot will going to show you? This box plot basically is showing us that those persons who are earning less than 50,000 are having a mean age of 35, and those persons who are earning more than 50,000 have mean age of 42, and maximum age of the person who are earning less than 50,000 is 75, or get 1,000 is 72. But data is very much few, right? And the minimum age for persons who are earning greater than 50,000 is around about 38. Clear? So with the help of this box plot, we got somewhat better idea, right? Now we're going to perform the data pre-processing, where we try to uncover more important aspects of the data. Now you are seeing that how much hard work we are doing on data, how much analysis we are doing on data before feeding it into the model, so that the model which we get, so that the outcome which we get is best and give us the best result, right? And it is the fight which we are fighting continuously, that the data or the hard work which we have done, which we are doing, give us the best results, right? So now we're going to move towards the EDA part of this one. First of all, we are going to make the canvas big. It's very important. So if I will not make this one, then what happens that the image will come very small, and the annotations of the graph or the bar charts which I will make will going to overlap each other, and will going to create a type of disruptions. Then to avoid that particular thing, I have to choose a canvas, a big canvas, so that everything would be separate, and there should be a proper understanding of each and every chart or each and every graph which I'm going to use. So this is my graph, and look at this graph carefully. So number of people, this is about the job profile in fact per class. And so as we have discussed earlier also, that maximum we have the private people, and these are of course the males, because hue is on gender. These are females. Local government, male, female, self-employed, and federal government working class, it would be definitely would be there in US. I think the central government would be there. Then self-employed, INC, some particular category, and without pay are no one, because you have to. you have to earn if you have to live, right? And race versus income, another very important graph. Oh, I'm back to pardon. I'm back to pardon. I'm sorry that it is about the income. In fact, it is about income. That for in private, if you are earning less than 50,000, they are very good number of people, and if you are earning less than 50,000, you have very few number of people. And the same way we proceed here also. Right? So I'm sorry for that. Then we have race versus income. That race is you're black, you're white, you're other Eskimo, Indian, or Asian Pacific. What if then what is the impact that you are of your on your earning? So you can easily see here that most of the wealth is being earned by the white people, and whether it is greater than 50,000 or less than 50,000 being earned by the white people. So what the data which the company is getting here is that subsidy will going to be there more for the black people, for other races, for armor Indian Eskimo, because they are very low earning people, right? And first of all, the total amount of people who are earning, and among them the proportion of those people who are black and who are of other race are are very much less. Not only less, they are also earning less in comparison to Americans. American have also a big group which is earning 50,000, but overall earning people are very less in comparison to Americans, right? So important point. Similarly, we move toward the box plot. Here, box plot simply says that if you are earning 50,000 per 50,000 per annum near about, then you have to work 40 hours, and if you earn more than 40,000, then you have to work a maximum, sorry, a median of around about 45 hours a week, and maximum would be 65 approximately, 65 approximately upper bound. So high income means high number of working hours, and it is also quite natural also that high income means more working hours, right? So now move towards the model. So what we did here is that we simply map the model into less than 50,000 and greater than 50,000. I just map them into 0 and 1 because logistic regression classifier basically get feed it with zeros and 1. It don't take any categorical variable, and then it convert it into probabilistic score, which I have told you earlier also. If it is more than zero point 0.5, it will be encoded as 1. If it is less than zero point 0.5, it get encoded as 0. Yeah, look at this one, right? It is now encoded as 0, 0, 1, 1, 0, and so on, right? So one more exercise which I would like to bring in your mind is that always keep an eye on your shape, the shape of your data, what the shape you are getting of your data. Always try to keep that thing in your mind. So I'm getting this shape now. Get dummies. Going to give me the values. Now get dummies is very important topic here. Dummies is basically being explained to you in your theoretical sessions also, but let me explain you. That suppose you have a variable, say education written by E, you have this education high school, intermediate, and BTech, right? So what this one we're going to do is that get dummies high school, intermediate, and BTech, right? So 0, 1, and 2. So what we're going to do here is that we can design 0, 1, and 2, and 1 0 has high school to 1 0 0, 1 has intermediate to 0 1 0, and BTech has 0 0 1 in this way. Clear? If you have more values, 3 in high school, again 4 high school, then if you're going to have 4 sorry, 3 and then 4. It's going to have 1 0 0 1 0 0. In this way, this is known as the concept of get dummies, or we also called it the label binarizer, or binarizing the labels, right? It is a very common exercise which is being done with the categorical data to binarize them, or to label binarize them. And you please take care of this particular thing, that before implementing get dummies, we have 15 number of columns. But as you have seen that in that example, the simple education, which consists of high school, intermediate and btech, converted into education underscore high school and education underscore intermediate and education underscore btech, right? So a single column converted into three columns. So that eventually depend upon the number of unique values are there in your data set. That number of and in your attribute, that number of columns get increased. So 15 is there, and then when I will run this one, I'm going to have these number of columns. So let us see how much they are being increased. Look at this: native country India, native country Iran. So whenever India will come, it will going to give 1 0 0 0 0 0. Number of unique attributes are there in the country India, Iran, Pakistan, whatever. They're going to assign the columns for them, and moment India will come, it will going to put one against India, rest of them will be zero. If any other country, say Puerto Rico comes, it's going to be one against them, and rest of them are going to have zero. If Scotland is there, one against Scotland, rest of them are going to have zero. In this way, it is going to work. Features. Now, one more thing. If you want, you can also do one thing. Get data underscore dummy dot shape. Look at the number of columns which have been increased from 15 to 97. So get dummy intuitively increases the number of columns. So we have extracted the target value also, dummy features, and this is very important factor. We have extracted values from there and put the value into into then we use train test split, which is used to divide the data sets of y. Since we have extracted y also, which consists of 0 1 0 1 0 1, we have put it this one here, and x is there, which is holding the whole data frame. And then we're going to split the data into two parts. Now we have two sets of train x and train y, test x and test y. So train x and train y will going to be there in one pair, and test x and test y will going to be there in one pair in the train test split. Then we have created a model. This is known as the model creation. This particular expression is known as the model creation. Remember this one. And then we feed the data into the model. Then this is the coefficients, right? This is the incident intercept. This is a prediction of the test cases. And misclassified samples are 2965, which are incorrectly classified from 42,000 something. And this is the confusion matrix. It consists of, this can be written in this way also. If I write it in elaborated form, it can be like this: 0 1 0 1. This is actual, this is predicted, it has 9, 7, 5, 2. Means that 9, 7 times false is being predicted as false, and 850 times what happens as true is being predicted as true. It is very good. And 390 times it happens that false is being predicted as true, and 2575 times it happens that one is predicted as false. Right? So accuracy is 781%. Let us run this one also. So we have these are the final set of columns which we can use to build. Now, can we improve this one? Let us see. What we did here is that we just remove some columns, and which is also known as dimensionality reduction. As I have told you that I am going to implement this for you. This will going to reduce some columns which I feel that not necessarily true and necessarily needed. And then I run this whole model again, repeat the process, then fit the model, and I found that the sample size remains same and accuracy won't affect so much, right? So what I did here is that I use another technique. Because what ML experts do, they just do the same thing there repeatedly again and again and try to do new things. I have some particular set of features. I implemented that in the logistic regression. I found 78% of accuracy. Then I tried to remove some particular features. Again, tried to implement that in the machine. Again, I found that the accuracy is still there. No further improvement. What I can do now, I have read this particular thing that normalization is very important characteristic. If we don't normalize the data effectively, then somewhere it affects the results. So what I did here is that I have taken another new technique where which I have told you earlier in also in the theoretical session that I divided data into two parts: continuous non-null and categorical non-null. Right? And there I segregated the data into two parts: continuous and categorical, and then in continuous I just normalize them and then join them again and then run the model and see the results. So this is the code which will going to put the kind of continuous values and categorical values in separate columns, and this is a syntax altogether. For column in column underscore null, if data underscore new column dot data type is object. It so object means basically what happens that in categorical variables, if your data is not continuous, it was treated as an object, right? So you're just going to append them. What this code altogether going to do is that it will going to divide your data, your final data, into two separate categories, that is null and non-null. Clear? So let us run this one. So these are your those columns which are categorical: education, marital status, relationship, and race. Similarly, continuous non-null will going to give you those columns which are non-null, don't contain any null value, but they are continuous. So this is just a representation technique. I don't want floating point numbers to be like in the form of exponents. Then this is my continuous data. Okay, some things are not defined. I have not run them. Okay, run from here. Okay, now it is work. So continuous data shape has this one. Similarly, I run again for the. Now what I'm doing here, which is very important. I'm just what I'm doing here is that I am normalizing the data. After then, I'm just building the frame for the continuous data, and this is what have done here. Now again I'm doing run I'm generating dummy values for categorical values. Of course, since I have segregated them separately, I'm just building all together new data frame again. I have my data frame, I divided it into I have my data frame, I divided into two categories, right? Categorical and continuous. And in continuous I'm performing transformation normalizations, and in categorical I'm going to perform the dummy value segment again. and then I'll just going to combine them together. That's it. Here I horizontally combining the data frames. Horizontally means these are two data frames, and I am just attaching them on the x-axis. Right, this is known as the horizontal stacking. That's it. And then my frame is ready. My final size of the frame is 45,222 rows are there and 39 columns are there. And I'm just extracting the value from there, inputting in the x underscore norm variable, calculating the length, running train test split, applying logistic regression again, predicting the accuracy, and I've got full accuracy and with no unclassified sample. It is very good classifier in fact, right? But ideally the right thing is that the right way to the right accuracy is 95 to 99, right? When you get full accuracy, then somewhere you are over judging your model. So it is an exercise for you from this point of time, that you do some other tweaking with the feature variables and try to build a more robust model, and try to do some changes in the features or try to incorporate something new and build the models. Okay, so with this we come to an end of this lecture. I hope you have enjoyed this. Thank you very much from my side.